Okay, so today we're going to talk about slope of a line. It's our topic. Who remembers from previous years? You guys dealt with slope. What is a slope of a line? Well, how do you describe it? What is it telling you? Jordan? Okay, it's rise over run of a line, right? Okay, so very good. Now, if the slope is rise over run, how can you measure rise over run of a line when the line goes on forever? Doesn't the line rise forever and run forever? Doesn't the line extend to both directions forever? So how do you even measure this rise over run? Did you see what I'm asking? Doesn't the line go on forever? How do you measure this rise over run? By the way, it's a ratio actually. It's ratio of rise over run. So how do you measure this ratio if the line extends forever? Go ahead and discuss with your group. What do you guys think? Do you see what I'm asking? So how about Emily? What did your group come up with? That's exactly right. Say it a little bit louder. Yeah, you find 2 points of a line. You choose 2 points, then you can measure the rise over run of a line, right? Otherwise, it doesn't make any sense. How do you measure rise over run of a line which extends forever? Well, the way to do that is you choose 2 points, okay? So once you do, so slope of a line, it's the ratio of rise over run, as you said, of a line. And of course, slope is rise over run, which is change in y. Remember, rise means you go how much you go up and down, right? And change in x. You gotta choose 2 points like this. Okay, that's the key. Must choose 2 points. Yeah, this triangle means change in y. Okay, sorry. So the key point is, of course, you gotta choose 2 points, and we're gonna call them x sub 1, y sub 1 for the first point that I choose, and x sub 2 and y sub 2 as the second point I choose. Does that make sense? Then you could look at the ratio of this rise over run. And who remembers the formula for slope? If you have these 2 points, x sub 1, y sub 1. Yes, Kenneth? Remember, it's rise over run, so. You remember? How do you get the change in y? Yes?
y2 minus y1 over x2 minus x.
Yeah, it's just simply, you could either do it y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This is the famous one. You could actually do it the other way around because, you know, the way you choose these points, it doesn't matter which 2 points you choose, right? You could choose the first point, this one, or the other one as the first point. It doesn't really matter. So if you do it the other way, it'll be y sub 1 minus y sub 2 over x sub 1 minus x sub 2. As long as you do it consistently. If you're going to start with y sub 2, guess what you have to have on the bottom? You got to start with x sub 2. If you're going to start with y sub 1, what do you have to have on the bottom? X sub 1. That's what you got to start with. Yeah, because it really doesn't matter which 2 points, which order you choose these two points in, right? So you get the slope there. And this is the famous one. So write this down. Okay. By the way, why is it y on the numerator? Why can't we have y in the denominator? Shouldn't we put the x's on top, like in alphabetical order and so forth? Yeah, Katie?
Because it's rise over run, y-axis.
Exactly right. It's because it's the ratio of rise over run, not run over rise, right? So rise, right, are given in terms of y coordinates. That y coordinate tells you how much to go up and down. X coordinate tells you how much you go left to right, okay? All right, so write that down. I'll wait. All right, so let's look at example 1. I give you 2 points. Can you guys find the slope of these 2 points? Yeah, we just showed you the formula. Every time you do this, I always tell you to label these. What do you think I mean by label these points? Yes?
Say which one's x1.
Exactly. So I want you to label it underneath like this. And then use, of course, the formula, okay? So do it this way, guys. Otherwise, you know, it's easy to make silly mistakes. And when you, of course, plug in, you should always, so you write down the formula M. Oh, by the way, which letter do we like to use for slope? M. Okay, M for slope. Anyway, and then when you plug it in, I want you to use parentheses, okay? So use parentheses, otherwise you can make silly mistakes. All right, go ahead, everybody find the slope. See what you get. All right, how about, let me ask Jack. Tell me what to plug in here. Mm-hmm.
Minus 4
Yep. Over?
over negative 4 minus negative 3.
There you go. Did you guys all use parentheses? Like I said, if you don't, you may make silly mistakes for not. Okay, so what did you get as the answer, Jason? What's the answer? What's the slope? Negative 1. How many people got negative 1? You guys are correct. Because don't you get positive 1 over negative 1? Right? Your slope is negative 1. Easy enough? Yeah? Okay, so please label these and then use parentheses. And of course, you got to use the formula. Try one more time here. Try one more. Oh, oops. Okay, actually, that was it. Let's go to the next example, okay? Okay, so the example 2 is a little bit different. I want you to try to sketch then the line that passes through 1, 2 and has a slope of 3/5. So can you guys sketch this line on a graph paper? If you have a graph paper right now, that's great. If you don't, it's okay. You could just, you know, do it on your notes. Can you guys sketch the line? By the way, how come I need to give you a point? Why can't I just give you the slope of 3/5 and say graph this line? Why can't I do that? Yes, Josh? Yeah, because the line could be anywhere. There are infinitely many lines that has a slope of 3/5, right? You don't know where to start. So you have to have a point, don't you, to graph a line. Okay, go ahead. Everybody graph this, sketch this line. I'll wait, okay? All right, who could help me how to do this? First of all, let's plot the point. Who could help me how to plot the point here? Is this too easy? Nico, what do I do here?
You flip 1, 2.
Yeah, where's 1, 2? How do I plot 1, 2?
You go over 1.
Right, so it's x comma y. So I always start at the origin. It says x is 1, y is 2. So I go to the positive 1, so to the right one and up 2, right? Is that okay? All right, so from here, Leo, what do I do? Because it says slope is 3/5. So how do I find the other point? Over here, asking, sorry, Leo. Sorry, Leo. Huh? Left 3 and down 5, are you sure it's rise over run? So I have to go. You want to go down, it's positive 3 or positive 5? Yeah, go up 3, there you go, go up 3 from here, yeah, from that point, because that's a part of the line. Go up 1, 2, 3, and then to the right 5. 1, 2, 3, 4, 5. Is that right? Okay, so that's positive 5. Now, Leo, can I think of this as negative 3 over negative 5? Because then what do I do, Leo? What can I do? Yeah, I could go down 3 from that point. 1, 2, 3. Oops, 3. 1, 2, 3. Yeah, and then what? Go left 5, right? 1, 2, 3, 4, 5. Here's negative 5, right? You see how I get these 3 points? Right? What do you think about these 3 points? They're all co-linear. That's got to be it, right? So you could. So on your homework tonight, they're gonna ask you to. They're gonna give you a point and give you a slope, and they ask you to find a couple of points. Okay, so this is how you find a couple of points. You don't have to just follow the positive 3 or positive 5. It could be negative 3 or negative 5. Same thing. So then, of course, you connect. There we go. Easy enough? Does that make sense? This is mine. Okay. Try this one then. Whoops. Let me move it up. Hold on. All right. Try this one here. It says point that the line goes through is 0, 5, and slope is negative 2/3. By the way, if the slope is negative 2/3, how are you gonna do the rise over run on this? It could be what? Negative 2 over 3 or what? 2 over negative. They all mean right negative 2/3, right? Okay, go ahead. Everybody try. I'll wait. Okay, and use several points to sketch the line. Okay, I'll wait. All right. So what do I do on this one? How about let's see. Who can I ask? Brandon, what do I do here?
First you put the point at 0, 5.
Yeah, 0, 5. So that's going to be on the which axis?
On the y-axis.
Yeah, that's right. Y-axis. Q. And then slope of negative 2/3. Let's try negative 2 over 3. Jilly, what do I do here? Go down 2, yes. And then to the right 3 is exactly right. There you go. Okay. I could get another point. Who could help me how to figure out the other point here? Shanna, what do I do? So I did negative 2 over 3, and then I could do positive 2 over negative 3, right? So what do I do here? I could also do? Go up 2 and to the left 3 is correct. And so if I do that, you see all these 3 points are going to be collinear, right? And then I just draw the line through it. Easy enough? Yes. All right, very good. Okay. All right, let's move on to the next example, okay? Now we're back to finding slope of 2 points, okay? Same thing that we did in example 1. Try this here. 8, negative 4, negative 3, negative 4. Go ahead, everybody try. I'll wait. Okay. Okay, this one's kind of interesting. Somebody tell me what to plug in. How about Leo?
Negative 4 minus negative 4.
Huh?
Negative 3.
Yep, and you get 0 over negative 11, right? What's the slope of this line, guys? 0. Isn't this interesting? What kind of line do you think this is? Michelle? Is a vertical line? It would be a horizontal line, right? Because you notice that they have the same which coordinates? They have the same y coordinates, right? In order for a line to be horizontal, you could see, draw any horizontal line. If you look at every order pairs of a horizontal line, what would you notice? Y coordinate is always same. Therefore, whenever you find a slope, right, rise over run, there isn't any rise. Think about it. If you have a horizontal line, is there any rise if you pick 2 points? No, there is no rise. Therefore, it's going to be 0 over something, right? 0 over some number. Therefore, horizontal line, guess what? Slope is going to be always? Yeah, horizontal line, slope is always equal to 0. Okay. Yeah, for what about these two? Go ahead and find these 2 points. I want you to find the slope of -6, -2, and -6, 9. Go ahead, everybody try. Oh, wait. Okay. All right, so did you all label it like this? X sub 1, X sub 2, Y sub 1, and so forth?
Yeah.
All right, so Narek, what did you get when you plug into the slope formula? Undefined. Don't you get this? You get 9 minus -2 over -6 minus -6, right? You get some number over 0, that's undefined. So what kind of line is this though? This is a vertical line, isn't that right? And it makes sense why slope is undefined, because what do you notice about vertical line? Every x coordinate is? No, not every x coordinate is 0. Every x coordinate is same. Therefore, is there any run? Is there any change in x's? No. So therefore, you're going to have 0 every time on the denominator. So it turns out for vertical line slope is undefined. Does that make sense?
Yes.
Right? Because for a vertical line, think about it. There is rise if you pick 2 points, but is there any run of a vertical line? No, there is no run. Therefore, right, it's going to be something over 0. So write this down. I'm going to give you some fun facts. Okay, here we go. Here's some fun facts about lines. If you have the slope of a horizontal line, by the way, look at horizontal. When you spell horizontal, there's a bunch of O's, right? That should kind of remind you of the slope is what? 0. Does that make sense? Because it's rise over run. For horizontal line, there is no rise. Therefore, it's going to be 0 over some. I wrote down as 0 over x sub 2 minus x sub 1, right? Because on the numerator, right, those y's are going to be the same numbers, correct? For a horizontal line. But what about for a vertical line? What's the slope? The slope of a vertical line is undefined. By the way, undefined, what can you say? Another way of saying undefined? No slope is the same thing. So is no slope same thing as slope equals 0? No, okay, please be careful. When you say undefined, it's same as no slope. Yeah, write this down. Right. Or no slope. Okay, that's not the same thing as slope equals 0. Slope equals 0, we have a slope. It's just 0. It's not 10, it's not 5, it's 0. So that has slope. But undefined slope, that's what we mean by no slope. Okay, so write that down. Okay. And as you can see, you know, it's rise over run. There is no run, so therefore the denominator is always going to be 0 for a vertical line, right? Think about it. Vertical line, there is no run. There is rise if you pick 2 points, but there is no run. Let's write that down. So, you guys remember this from last time I showed you the free nice graphing calculator? Let's put a line. Do you guys remember how we draw a line? Y equals to what? Yeah, y equals to mx plus b, mx plus b. And notice, I can remember this is nice. I could change the value of m. Notice, look, when m is 1, right? You get the slope. Let me change it to m equals to 0. What would happen if I change the slope equals 0? What kind of line would you? Yeah, you get a horizontal line, as you can see. Right, you get a horizontal line, right? Do you see that? Okay, let me change it to so you can see it better. Projector mode, you can see a lot better. Does that make sense? All right. Now, what happens if I change the slope to if I increase the value of slope? What's happening to the line, guys? So look at it's getting steeper and steeper. Oh, the other way also works out, right? It gets steeper and steeper. Now, look at the positive slope. What do you notice about positive slope? If as you go from left to right, what's happening to the line? It rises, doesn't it? What about for negative slope? As you go from left to right, what's happening? It goes down, right? I mean, of course, you have to always go from left to right, because if you don't, if you go from right to left, it's going up, right? Or you could say the other way, right? You know what I mean? So as you go, you gotta be consistent. Like even for positive slope, some people may say, oh, if the slope is positive, the line must go up. But is that true if you go from right to left? No, if you go from left to right to left, it goes the other way. So as you go from left to right, it rises, right? If you have a positive slope. If you go from left to right, if you have a negative slope, it goes down. Okay, and also as the slope, if you increase the slope, it gets more steeper. Do you see how it gets steeper? Even the negative side. Does that make sense? So those are the fun facts that I'm going to write down for you. So second one is the line with positive slope rise to the right. And do you see why it's important to say rise to the right, right? Because, you know, if you go the other way, it goes down, right? And of course, if line with a negative slope, what happens as you go to the right? For negative slope, it goes down. Okay, it falls to the right. So write this down. These are the two other facts. Line with positive slope rise to the right. Line with negative slope falls to the right. So that's kind of nice to know. Okay, so go ahead and write it down. What about this? Here's the last fun fact for today. It says the greater the absolute value of the line slope, the steeper the line, right? Why do you think I have to say absolute value of a line slope? Yeah.
Because even if the slope was negative, it would still be.
Yeah, it could have slope of negative 100 versus positive 100. They would be both steep, right? So that's why you have to say, okay, so the greater the absolute value of the line slope, the steeper the line. Okay, so write that down. I'll wait.